So you look at another example. This example is going to be a very popular one. So we're going to talk about a lot of different pieces in this one. So make sure that you do watch the entire video because this is the same types of examples you're going to see on exams. So a sample of radioactive substance weighs 36 milligrams. 1 year later, the sample weighs 29.5 milligrams. How much will be left after 3 years, and what is the half-life of the substance? Okay, so before we get to understanding what half-life is, the idea behind radioactive decay is that this is going to decay exponentially. So we have this function, a of t, is going to be our a sub 0 e to the kt. This is our general exponential growth and decay model. Now remember, our a sub 0 is the initial amount, and so we start out with 36. So my function becomes 36 e to the kt. So similar to the first example, our goal is to solve for k. So we want to solve for k. What we want to use is the fact that 1 year later it weighs 29.5 milligrams. So I have 29.5 is what remains here when I have 36 is equal to e times k, and my time is 1. So I have 1 year later. So my time I'm just using is years. So I need to divide by 36 because I need to get the exponential part by itself. So I have 29.5 divided by 36 is equal to e to the k. Now to solve for the exponent, I take the natural log of both sides. So I take natural log of 29.5 divided by 36 is equal to natural log of e to the k. Move the exponent down because these are the rules of logs. So I have natural log of 29.5 divided by 36 is equal to k times natural log of e. Natural log of e we said is equal to 1. So that says that k is equal to natural log of 29.5 divided by 36. So this is the k that I'm going to plug back into my function here. That was the whole goal of what we did. So my function a of t is equal to 36e, and this is raised to the natural log of 29.5 divided by 36 times t. So this whole thing is in the exponent. So the first question asks, how much will be left after 3 years? So what that means is we're going to plug in t is equal to 3. So this says that t is equal to 3. So I'm looking for a of 3 is equal to 36 e to the natural log of 29.5 divided by 36 times 3. So let's see, how do we plug that into the calculator to make sure we get the right answer? So I'm going to type in 36 times. Over on the left side, there's this e to the x, so I press the second natural log button. That goes to e to some exponent. Now in the exponent, I'm going to have natural log of 29.5 divided by 36. Close the parentheses for the inside natural log, and now I multiply by 3. That's still in the exponent, so I close the parentheses. This says that a of 3 is equal to 19.8 milligrams. So that's the expected amount of how much will be left after 3 years. So this is decaying very quickly. Now, moving on to this discussion of half-life. So what half-life is the amount, this is the amount of time it takes for half of the original amount to remain. So if we start out with 36, the half-life will be the amount of time that only half of it remains. So if we think about what that means is if my general function given down here of a of t, what I'm looking for is what happens when I have 18 milligrams remaining. Because this amount remaining after 2 years, I want that to be half of the original amount, which is 36. So 18 is equal to 36 e to the natural log of 29.5 divided by 36 times t. Now we're trying to solve for t, so t is in the exponent, so I need to get this exponential by itself, so I divide this by 36. So I have 1/2 is equal to e to the natural log of 29.5 divided by 36 times t. Now I need to try to get the exponent down, so I need to apply logs to both sides. So I have natural log is equal to natural log of e to the natural log of 29.5 divided by 36 times t. Now this whole exponent is the full exponent. I'm going to bring that down. So I have natural log of 1/2 is equal to natural log of 29.5 divided by 36 times t times natural log of e. Natural log of e we know is equal to 1, so to solve for t, I just need to divide this over. Natural log of 29.5 divided by 36. So divide that over. So my t is natural log of 1/2 divided by natural log of 29.5 divided by 36. So plugging this into the calculator, I'm going to get natural log of 1/2 divided by natural log of 29.5 divided by 36. Close the parentheses. And what I see is that this is going to be 3.48 years. Now that number makes sense because we said after 3 years there was 19.8 milligrams remaining. So that's not quite half, it's a little bit more. So we need a little bit more than 3 years. So intuitively that number makes a lot of sense for us. So this is again the style of question that you should be expected to do on an exam.